Today I'm going to talk about the programming environment Dolphin Smalltalk. I'm going to talk about why I love it, the crazy features that it has, why I think it blows just about any IDE out of the water. I'm going to talk about Smalltalk as well, and Dolphin. So Dolphin is a Windows program, so if you're looking for Linux development, well, you could run it in Wine, but I'm not sure how that experience goes. So Dolphin is an image-based system, kind of like Lisp. And what you see in front of you is what you would call the IDE, or it's actually the image running the IDE. So at the bottom you have like bytecodes and a virtual machine, and it's running this IDE. So if I go into the source methods, and yes, all the source methods are here. The only thing you won't see is very low level stuff like beyond the VM. So we can go into, let's see, what can we see here? We can go into the Dolphin system. We can go into the IDE. We can change anything we want. So like in Visual Studio Code, maybe you can change some stuff, but can you change everything? Like literally I could change every single aspect of what you see in front of me, all these code browsers, how they function, what they look like, what a mouse click does, etc. I could change all of that because the system is completely customizable and it's running in Smalltalk, and you have access to everything. So the first thing I'm going to talk about before I get into the features of Dolphin Smalltalk and Smalltalk in general is the incredible code management that it has. And this is something that could be replicated by other IDEs, but I just don't see it. And so let's just go to a package here. Let's go to my chess package. And you can see here's all my classes, right? So let's click on a class. Let's click on chessboard. So you can see here I have some protocols for different methods that I have organized. These are just automatic protocols that you can set. And you can set a method public or private, but it doesn't really matter if it's public or private. You can still call a private method. So you can see here on the right here I have all my methods. So already you can see that it's organized much better than an IDE where you might have to see kind of an overview and click down and scroll through code. Like I don't have to scroll through a code file to get to the method I want to. For instance, if I want to go to active player, I click on active player, here's the source. I want to go to copy board, I go to copy board, here's the source. And you'll notice that I have 3 separate windows open. Because this is just so well structured, you can open multiple views. I can have multiple classes open in each view. I can have multiple workspaces open so I can execute code live while the system is running. I can pretty much do whatever I want. And I get to see more with my windows. I could put another 4th window here on my ultra-wide monitor. But you'll also see I have a system transcript here, which is like a console output. And you can see I've got some more of the IDE here. I can usually just move this to another monitor and work with the extra space I get. So let's talk about some of the killer functionality. So the first thing to realize is this is a live system. So when you code, when you're developing, it's completely different than when you deploy. When you deploy, you create an executable that's very small and your customer would run it. And they don't get access to any of these tools, but while you're developing, for instance, I'll open a view here, my chess program, and you can see I have a little GUI here, and there is a kind of a Visual Basic inspired GUI designer, which is amazing in itself. You can see I've got my code here. Now, I'm just going to leave this running. I'm not going to shut it down. It's running now, but I still have complete control of everything. I can change any method I want to, and it will be immediately reflected in the running code. So let's go to the chess program, the chessboard view, and let's put a breakpoint in one of these methods so we can go to on button up, which will be triggered when I let go of the mouse button, when I click on the chessboard view here. So I'll just throw in self halt, and now if this code gets executed, notice I didn't have to restart the program. You can see we have a breakpoint, and you can see the execution stack here. But what I can do is click debug, and we get this amazing debugger. Now here's all the stack frames. I'm in on button up. I came from on left button released. You can see this is where it called on button up. So, you know, I can do the normal things like step over. Okay, but if I want to, I can just go to debug, restart, and I'm back to where I started. With more or less the same state that I started with, which is not always true, but for more or less for debugging purposes, it really doesn't matter. And so you can see I can step over some code here, and now I can literally click in the debugger here and write out some code. So let's say I just assign this variable square of mouse. Let's say I want to see what it is. I can type in the variable name, and I can print. Okay, it's an undefined object because I didn't get that far in the code yet. Okay, and because I typed some code in, I actually ruined the formatting. I'm just going to delete that and start over. I'm going to restart this. You can actually make changes and restart from where you started. You can even go back and make changes, which is just amazing. I mean, you really can't do that in most languages. You can't, you know, pause execution on a breakpoint, go back like 10 method calls, and then change the source, and then start from there. You know, you can't do that. Let's see here. Okay, so I've got this halt. I'm gonna step over. Okay, so I'm gonna type in, or I'm just gonna highlight the square of mouse variable name here and go to display it. Just Control D. And you can see this is the display of the object. It's 5@4, which is a point object. That's how you specify point in Smalltalk. You use the @ symbol. So this is X and Y. So if we didn't understand that, what we can do is push Control I, and we can actually inspect. Hold on, let me actually highlight that. Okay, so I'm going to highlight square of mouse and inspect it. Okay, so I'm going to highlight square of mouse and inspect it. So you can see, we see the class here, it's a point. We see X and Y variables here. We can literally change them if we wanted to, just for debugging purposes. You don't have to restart the whole program. You can just change things where you are. So yeah, you can see there's incredible functionality, and you can even kind of code in the debugger, which is really fast. So like, let's say I wanted to add a method call here, and so I'll say self crazy method. So now I can just restart the frame here and get down to my method call. I'm not sure. Where did I put that? I'm not sure if I actually changed the method I was on. Let me try this again. I'm gonna restart this frame. Okay. So I'll just say self crazy method. I'll save it. And when you save it, it starts over, so it knows to do that. So I'm gonna step through the debugger here, get to our method call. So we're sending the message crazy method to self, and it's just a function call with no parameter. So we step over that, and we get does not understand, failed message. So the object that was sent the message does not understand the message, right? So it handles that. Your program doesn't crash. You don't have to restart. Um, you can handle this however you want. You can do all sorts of cool metaprogramming. But what we're going to do is go debug, implement in chessboard view. And now we can just type the code in. So we can say answer, let's just answer, this is a crazy, oh, that's not a string, that's a comment. This is a crazy method. So we're just going to return a string. I'll save that. And then we can start stepping. And now we are back past that. What we really want to do is get the string. So we'll say transcript show self crazy method, and we'll send a carriage return to the transcript. So we'll save that. Let me get my transcript here. Okay, so you can see we've been just coding in the debugger. Didn't have to go back to any code. We just code as it comes along. And you can see this is a crazy method in the debugger. So we sent that message to the transcript. And we did it all live while our program was running. We didn't have to stop and recompile the code changes. You know, normally when you compile a code in like Visual Studio Code or something, you compile the whole project or you compile a file or something. But in Smalltalk, you just compile a method and it compiles live. It's all dynamic. So you see instant changes. You can do this while a game is running. For instance, I could change a method, change some kind of data. I could change the color of like every game object I had or something in a game. So I could pretty much do whatever I want while it's live. And you don't have to code live like this. I'm just going to close this. So, of course, you can code, in the source. You can just make changes, test it. You can use the transcript, or you can do debugging. It's really easy to debug stuff because you can find out the type of everything and you can step through. You can execute arbitrary code to find out what's going on. Okay, so those are some of the cool functionalities that are in Dolphin. Let me show you some other cool functionalities here. Let's open up a view composer. So Dolphin is a Windows native program. So the GUIs that you build for your applications are styled like in Windows theme. They're not like some weird virtual machine, custom GUI, right? They're Windows GUIs, and they're fairly customizable. You can change the look a lot. And new versions of Dolphin have updated some things. So let's go into the view toolbox here. Let's create a shell. Let's see here. Let's go to a new shell view. Let's go to new shell view. Okay. So you can see we can kind of build a GUI. We can put in a checkbox. We can put text in. We can put numbers. We can use trees. There's different dialogues and splitters and stuff. You can also customize the GUIs in code, so you can have very dynamic GUIs. I'm not totally good at using this, so a lot of this stuff I just figured out slowly myself, and I can't really show it that well, but there's a lot of stuff you can do here, and you can make pretty good looking applications. And this is basically the shell of your application, and you kind of wire it up with code. You would put in like one of these elements. You could like name it, and then you could refer to that name in code. Wire up all the components and make sure they're working like you want them to. So there's another feature. And now I just want to talk about the Smalltalk language itself and how easy it is to learn. Pretty much all you need to do is call instance methods, class methods. So these are like static methods in Java or something. They're methods that exist in the class and they don't exist on an instance of a class. And the class can have its own variables. You can see there's class variables here. You got your instance variables listed. A lot of this stuff can be done pretty quickly, like you can right click here and just add a variable, etc. So let's talk about Smalltalk code. Let's see if we can read this. Okay, so the function is legal moves, and here's just the description, answers a collection of legal moves. And then here we've got a temporary variable that will only exist in this method called all legal moves. You can define more there just by putting a space between the names. So what we do here is we assign to that temporary variable a new ordered collection. So what we do is we take the ordered collection class and we send it the new keyword, right? So it goes right to left. You have your object on the left and you send messages to it from the right. And you can chain messages, so we can say ordered collection new, and we could say, like sort. We could just keep chaining messages to it. If you want to refer to the object, you can say ordered collection new yourself, and it'll refer back to the object you send the message to. So we sent new to ordered collection. So yourself would return the ordered collection class. So pretty much anything you want to do, you can do. So we got pieces do, right? So we take this collection called pieces and we iterate. So we've got each piece gets put into this block here. This is a block which is kind of like a lambda function. It's just a a block of code that you can send messages to. And so we're just sending a block to the do message, and we're sending that to the pieces collection. Each iteration through the collection will be assigned to each. So we go each, and then we send this message, legal moves on board self, to each. So we get all the legal moves on the board, and then we iterate over those. We do a do again, and then we add to this collection we made here, all legal moves add X. So it's just adding all the legal moves to this collection. And then pieces select each size is greater than 0. I'm not really sure what that does, but I'd have to look at my code again. And then we answer all the legal moves. So let's look at some more code here and just see if you can parse what's happening. Move is legal from A point to A point 2. That's pretty self-explanatory. Self, piece can move from A point to A point 2. If true, do this block. If false, do this block. So the syntax is very simple, and what I'm going to actually do is Google the Smalltalk syntax cheat sheet. Smalltalk syntax on a postcard. I think that's what we're looking for. Okay, so this is the complete syntax of Smalltalk. So you can see this is a method, right? And it's named example with number. It takes an argument x. This is a comment, and it explains what the method does, which is also the explanation of the Smalltalk syntax. A method that illustrates every part of Smalltalk method syntax except primitives. It has unary, binary, and keyword messages, declares arguments and temporaries, but not block temporaries, accesses a global variable, but not an instance variable, uses literals, array, character, symbol, string, integer, float, uses the pseudo variables true, false, nil, self, and super. It has sequence, assignment, return, and cascade. It has both 0 argument and 1 argument blocks. It doesn't do anything useful though. So this y is a temporary variable for the method. So we've got true and false not. True and false not. So this is just Boolean logic, right? And then we've got nil is nil. So we send a message to nil. We put this in parentheses because we don't want to interfere with these other messages we're sending because we'll get an error. So we start over here. We take the nil object, which is a special Smalltalk object, right? And we send it is nil. So that will just be true. And this code right here doesn't do anything, but it just demonstrates how the syntax works, how to send a no argument message to an object, right? So we say if false. So we have an if false message with the colon. That means we're going to have an argument. And it has one argument. Now, if false, if true is, 2 arguments. And there's 2 messages with a colon there. But so if false, and then we have a block. And so what this does is, if this evaluates to false, the program will halt, just like I showed you. So whatever's in the block will get executed, right? It's pretty simple. So then we've got a variable, this y variable, and this is the assignment operator. So y becomes self size plus supersize. Now self refers to the same object that's executing this method currently. And size would be like if it's an array or something, like how big the array is, etc. Plus supersize. So super refers to a superclass. So yeah, of course, Smalltalk is like the original object-oriented system, and you've got a class hierarchy. So you can have a class and a superclass, and you inherit methods and properties from the superclass. So we send a message to the superclass, which will basically just run the methods from the superclass on that instance. Okay, so supersize. Here we have, I think, an array, and we have in the array we have a character, a symbol, and a symbol is just like a unique identifier. It's not a string. And then we've got a string with a character in it, and then we've got the number 1 and a float. So we've got an integer and a float. So we take this array and we iterate over it. We say do. And each time through the iteration, the variable will be assigned to each. So we say transcript show each class name. That's pretty simple. And then this is a cascade operator. So what it does is it sends the next message to the previous object. So whatever this show message was sent to, which in this case is the transcript object, this message will go to that too. So show each print string, and then one more show and an empty string, and then we close the do block. So like I said, when this runs, each element will get that applied to it, and it'll show on the transcript the class name, how it prints. And then finally, this is the return operator. So we return the value from this method. We could return a collection. We could return any object really. And then just return x is less than y, which is a Boolean operator. So it'll be either true or false. So that's the whole syntax. Now that may have seemed a little bit complicated if you've never seen Smalltalk before, but if you compare that to whatever you're coding in Visual Studio, this is the whole syntax for everything. Like once you've learned this, you've learned the whole code base, right? But in C or C++, you've got all kinds of brackets, you've got special ways of doing things that don't make sense. You've got all kinds of special syntax and macros and like just all kinds of nonsense. And it takes a long time to learn all the syntax for a normal language. Some are better than others, but Smalltalk is incredibly easy. So if you actually wanted to use Smalltalk, Dolphin or Pharaoh or whatever it is, you can get started very quickly. I think some people look at the language and see it's not like a C style code. Once you understand it, it's actually very simple, and you can do things above your pay grade because it's so easy to use. If you can find a Smalltalk library for something, you can use it very easily. It's not very difficult. You don't have to worry about all kinds of things. If you don't understand a type or something, you can just look at it in the debugger. You can look at all the methods. And now let's talk about some refactoring stuff and ways of finding what you need in the system. So let's look at a method here, legal moves. Let's right click on this. Let's go references to legal moves. And you can see only this method calls it. And it's selected where it's being called. Okay, so let's go to another method here. Let's find the references to next move here. And you can see all these classes call it, so you see all the references right away. I know you can do this in other IDEs, but just something about the way that Dolphin does this is just so much faster, so much easier. You know, let's say you wanted to delete the method call. You know, you can just go here, you can just delete the code, save it, and it disappears from the list. So it's really easy to just go through everything really quick. Now, other things you can do. Let's go to a method that I've actually been changing. Actually, I'm not sure what I've been changing, so I'll just change something real quick. Let's go to create fen and let's just put some code in here. Put some more code in here. This is ridiculous code, but I'm just demonstrating something. So let's save that. And now what we can do is we can right click on create fen, browse other change history. And if we expand this, we can see the full method and we can go through all the changes real quick. So we can just see the changes visually, and you can still diff. We can diff here and you can see the diff like you would get through JIT or something. We can restore the method to how it was, etc. Even if your image crashes because you did something that was too powerful for your system and you just crashed the image, all of the changes are written out to files on the disk. All of the source code is written out to files on the disk. So a lot of people, when they hear image-based development, they get caught up on that and they think that you're not actually saving code in files. Well, actually, if we look at the files, okay, so here are my files. These are my packages. Let's just look at something here. Let's look at chess conversion. Okay, so there's different file out formats. You can file out every class, and that's what I did a long time ago. That's why this folder is so populated. But if I just go to the pack file here, this is where all the code is. And I can just edit this with a notepad. You can see here this is in a package format, but it's all just plain text. And sometimes I have actually just edited code in the package here. If there was some reason the package wouldn't load or something, I could just fix the problem. So yeah, it all gets written out to files. Now, that being said, you don't really want to use the files. We can look at one of these class files. So you can see the class files are a little bit easier to read, but you still don't want to edit those. So you just open the IDE and you just load your changes. You load your package, you load your class. There's a lot of ways to load code in Dolphin from other Smalltalks, and so you just load your code in and there it is. You don't need files. You have files, but you don't need them. There is a pretty good source control system that is pretty interesting. I'm not going to show it here because I don't have it set up. Now, as far as what you can do with Dolphin Smalltalk, you can make Windows apps. And as you might expect, there is the ability to interface with Windows in general. So if we look in here, we have ActiveX control browser. So you can use ActiveX, and ActiveX is kind of old, but there is actually a lot of interesting stuff you can interface with. A lot of stuff in Windows you can interface through here. You can see all the ActiveX stuff that's like already installed on my system. A lot of Microsoft stuff. There's all that. You can also download or buy ActiveX controls and use them. It's not always the best option, but if you really need something to happen and there is a good ActiveX control out there and you're willing to spend a little bit of money, it's kind of interesting to have that ability. Now, in terms of interop with C and C++, there's a lot of stuff in here for interfacing with it. You can see we've got like types, we've got external fields, external descriptor, external library, and you can actually wrap C methods in a library. Like I did this with Raylib. All I had to do was say where the DLL was, and then say what the message format was. And I could do that by just looking at the Raylib cheat sheet and kind of typing in a template for the method call. I just have to kind of convert the types. Like if it's a number, I have to convert it to the right number of bits. It's not that hard, but it is a little bit difficult at first. If you don't know C, especially if you're already familiar with C, it'll be extremely easy for you. So you can load code in Dolphin. It's extremely easy with C. It can be done with C++. There are other code bases you can interact with. There is a Java library. There's a .NET library. But now I'm going to get to the downsides of Dolphin Smalltalk. And Smalltalk in general, it's not that popular. There are a lot of people that write code for it. There are a lot of packages that do interesting things. But a lot of the time, you're going to need to make changes yourself. You might not find what you want. If it existed before, you might not be able to find out where to get it. I actually have a lot of Dolphin packages that a lot of people, I think, just don't have access to anymore. There's like a .NET bridge, there's a Java bridge, and there's different stuff you can use. So yeah, it's not that popular, so you might have to code some more stuff yourself. Like I coded a WebSocket client myself, and it wasn't too hard. And like I said, you can interface with C, so if you find a good C library that does what you want, like Raylib or just any random C library, it's pretty easy to write a wrapper for it. And then you can use that functionality. It doesn't always work out how you want. I think it's the code is good in the system and it does what it does right, but you might make a mistake yourself, so it might be hard to debug some of that stuff. Other downsides are because you have access to the full system. Like you can literally do things like object become class or something like that, right? And it's gonna just crash your system immediately. So you have all the power to crash your system. So sometimes you have multiple images, you have to start a new image because your image gets corrupted. But as long as you've been saving your code, as long as you can recover your code from the change files, there's a change file that gets made that saves every method save you do. So you can recover your changes even if the image crashes. So yeah, that's some of the stuff I like about Dolphin. And for certain projects, whether it be like a video game, you can see here I'm making a chess client. This is a client to the Internet Chess Club. And I'm also using it more as like a chess GUI that I'm developing that can do a lot of different stuff. And it has a different interface. There's like a tree view that shows all the moves in like a tree format. And you can click on the moves and you can really do a lot. It's really easy to build a Windows app very fast with it. Certain tasks it's very useful for, especially if you're building in Windows and you want a native Windows look and feel. You want some kind of integration with the C library maybe. As for speed, I'm pretty sure it's faster than Pharo Smalltalk. I don't know if it's faster than Java. I think it's pretty fast, but it's not going to be as fast as C code, obviously, because I think it's interpreted or whatever. I'm not sure if there's JIT compilation. I'm not really sure what they've got going right now, but it is pretty fast for a Smalltalk. And other than that, let me just look through here real quick. There's a lot of examples. There's documentation right in the image here. You can see there's some documentation. Pretty much, you can just scroll through here and find out a lot of stuff. It's always amazing when someone doesn't know about this and they finally learn about it and suddenly like everything makes sense. So you can see there's a lot of instructions for external interfacing, just Smalltalk best patterns. See how to make a new library, do all this stuff. You can see here's where they wrapped some C interface. And then basically you just put the function name in. You've already specified the DLL file, and then you can just call the function. So it's not that hard really, as long as you can figure out like if this is an integer, what does it map to. Sometimes you have to make some structure for the structures and the interfaces that you'll be using and passing around and stuff. So like if you're going to receive like a struct, you're going to need to create a placeholder for that. Yeah, I think that's about it. Pretty much, I'm always surprised what Smalltalk and Dolphin Smalltalk can do. So I just wanted to share the main reason I like it. It's always easier to develop in Dolphin than other languages if it'll work. Sometimes I run into a problem where I really need a certain library or some functionality that's not programmed in yet. And eventually I just end up programming it myself if I can. Yeah, I think Dolphin is a great system. If you're just creating basic Windows apps, it might be one of the best because you can use a view composer, you can compose the code really fast, you can write some code that does what you want. There's a lot of functionality. One more thing I'll mention is just documentation. Like, let's say I wanted to look at the documentation for this library here. Pretty much all you do is just open the code, and some of the methods might have comments, right? Some of the classes and methods might have comments. But even just looking at the code, and because it's so easy to look through the code, you can just look at the methods. If you don't understand something, you can do something like browse class references. You can find everyone that refers to this, no one in this case. Let's go to Socket 2, browse class references. You can see everything that uses that class. You can find things really fast. So you don't really need documentation. The documentation is in the image. It's in your IDE. It's the best IDE I've seen so far anyways. So, yeah, those are the reasons I like Dolphin Smalltalk. If you've learned something, if you're going to use Dolphin, if you thought this video was interesting, leave a comment. Hopefully this video recorded okay. So anyways, thanks. Bye.